Imagine standing barefoot on a mud brick rooftop in ancient Mesopotamia. It is somewhere around 1600 BCE. The air smells of river silt and cedar smoke. The city of Nippur hums below you, tens of thousands of people living their complicated, urgent, deeply human lives. And above you, the sky is doing what the sky has always done, putting on the greatest show in the universe, completely free of charge, every single night without exception. The man standing next to you is not a priest, though he dresses like one. He is not a soldier, though kings would go to war based on his words. He is something older, something stranger. He is a watcher of the sky, a scribe, a translator of heaven's language. And tonight, he is writing something down on a wet clay tablet with a reed stylus, pressing tiny wedge-shaped marks into the surface with a practiced, unhurried hand. You lean over his shoulder. The marks say something like this: "A star with a tail appeared from the region of the great water. It moved against the wind. It came from a place that is not ours." He looks up at you. He doesn't smile. This is not a time for smiling. What he has just recorded, he believes, is a message from the gods. A warning. A sign that something enormous is about to change in the order of the world. He was right. He just didn't know it would take 4,000 years to understand exactly what he had seen. On July 1st, 2025, a telescope in the Atacama Desert of Chile, a robotic eye bolted to a concrete pier on a remote hilltop, scanning the sky in automated silence, detected a faint smear of light moving through the constellation Sagittarius. The telescope was part of a planetary defense network called ATLAS, Asteroid Terrestrial Impact Last Alert System. His job was to watch for space rocks that might threaten Earth. What it found instead was something far more extraordinary. Within hours, astronomers around the world began checking and rechecking the numbers. Within days, the verdict was in. The object, initially tagged with the unglamorous catalog designation A11PL3Z, was moving too fast. Way too fast. Its trajectory was hyperbolic. That single mathematical fact changed everything. A hyperbolic orbit means the object is not gravitationally bound to our sun. It did not come from our asteroid belt. It did not come from our Oort cloud. It did not come from any corner of our solar system. It came from somewhere else entirely. It came from the abyss between the stars. The astronomers named it 3I/Atlas, the third interstellar object ever confirmed in human history. And as weeks of observation piled into months, as the world's most sophisticated telescopes turned their eyes toward the strange visitor Hubble Webb tests, the Parker Solar Probe, the Mars rovers, the Europa Clipper, the picture that emerged was not just scientifically astonishing. It was, in a way that is almost difficult to put into words, ancient. This is that story. A story that begins not in Chile in 2025, but on a rooftop in Nippur around 1600 BCE. A story about what humanity has always known, deep in its gut, about the universe it lives in, about visitors from beyond, about things that come from the darkness between stars, trailing fire and dust, and pass through our little corner of space as if we were barely worth noticing. Let's go back to the beginning. Not our beginning, the universe's beginning. 11 billion years ago, give or take a couple 100 million, which in cosmic terms is basically rounding to the nearest integer, there was a star. We don't know its name because no one was there to give it one. We don't know exactly where it was in the Milky Way, though astronomers believe it lived in what we call the thick disk, that ancient, densely populated middle region of our galaxy, full of old red stars and the ghosts of dead ones. It was, by the standards of stars, unremarkable. Medium-sized, warm, probably surrounded by a disk of gas and dust, the same kind of disk that would eventually, in our own star's case, become Mercury and Venus and Earth and Mars and Jupiter and every other rock and ball of gas circling our sun. In the outer regions of this disk, far from the heat of the central star, temperatures dropped low enough for ices to form. Water ice, carbon monoxide ice, methane ice. These ices gathered around specks of dust and rock, slowly accumulating mass through billions of gentle collisions, building themselves into something larger. The process is called accretion, and it is, in a very real sense, the same process that built you. You are made of stardust that accreted. So is 3I/Atlas. But 3I/Atlas was unlucky, or lucky depending on your perspective. At some point in the chaotic early life of that alien planetary system, perhaps jostled by a giant planet migrating inward, perhaps gravitationally disturbed by a passing star, perhaps simply the victim of the mathematical odds that govern the formation of solar systems, the icy body that would eventually become 3I/Atlas was flung outward, ejected, cast into the dark. That ejection happened approximately 11 billion years ago. For context, Earth didn't exist yet. Our sun hadn't formed yet. The universe itself was only about 2 or 3 billion years old when this frozen orphan began its journey through interstellar space. Since then, it has been drifting through the cold dark between the stars at a velocity of roughly 58 kilometers per second relative to our sun. That sounds fast. It is fast. It is faster than the speed at which Earth orbits the sun. But on galactic scales, 58 kilometers per second is practically standing still. At that speed, crossing the Milky Way, which is about 100,000 light-years wide, would take roughly 500 billion years. So 3I/Atlas wasn't crossing the galaxy. It was just drifting, slowly by cosmic standards, patiently if cosmic objects could be patient, traveling through a universe that was, from its perspective, completely empty. A cold, dark, featureless expanse of nothing, punctuated only by the occasional distant glimmer of a star too far away to provide any meaningful warmth. 11 billion years of this. 11 billion years of absolute silence. 11 billion years of being the universe's most alone thing. And then, sometime in the recent past, recent by cosmic standards meaning within the last few 100,000 years, the trajectory of 3I/Atlas brought it into the gravitational influence of a particular middle-aged yellow star on the outer arm of a particular spiral galaxy. Our sun. Our home. And in 2025, we finally noticed. Let's talk about the numbers for a moment, because the numbers here are the kind that should make your brain do something involuntary. When 3I/Atlas was first detected on July 1, 2025, it was already inside the orbit of Jupiter, roughly the same distance from Earth as Jupiter is. And it was moving at approximately 137,000 miles per hour. That's the initial figure. That's what it was doing when our telescopes first saw it. As it fell toward the sun, pulled by gravity, accelerating like a stone dropped down an infinitely deep well, it picked up speed. By the time it reached perihelion, its closest approach to the sun on October 29, 2025, it was moving at approximately 153,000 miles per hour. 246,000 kilometers per hour. That's fast enough to cross the continental United States in about a minute. It passed within 1.36 astronomical units of the sun, just inside the orbit of Mars. Close enough that the Parker Solar Probe could study it. Close enough that the Mars Reconnaissance Orbiter and the Perseverance rover on the Martian surface both turned their instruments toward it and gathered data. On December 19, 2025, it made its closest approach to Earth, at a distance of about 170 million miles, nearly twice the distance from Earth to the Sun. Far enough that there was never any danger. Close enough that amateur astronomers with decent equipment could see it. Close enough that every major telescope on Earth and in orbit had it in their crosshairs. And then, as it was always going to do, as its hyperbolic orbit made mathematically inevitable from the moment of its discovery, it left. It curved around the sun and headed back out into the interstellar dark, picking up speed as it went, carrying with it everything it had gathered in those few months of solar warmth, and heading back toward the cold silence from which it came. The Transiting Exoplanet Survey Satellite, TESS, tracked it in January 2026 as it headed outward. By then, most of the world had moved on to other news, but astronomers were still watching, still measuring, still learning. What they learned is the part of this story that begins to echo something much older. The Hubble Space Telescope estimated that the nucleus of 3I/Atlas, the solid, icy core at the center of all that activity, was somewhere between 440 meters and 5.6 kilometers across. That's a wide range, and it reflects the difficulty of measuring an object that is, even at its closest approach, hundreds of millions of miles away and shrouded in a cloud of dust and gas that can be kilometers thick. But even at the smaller end of that estimate, we're talking about a rock roughly the size of a large city. At the larger end, you're talking about something that would dwarf Manhattan if you set it down in New York Harbor. The James Webb Space Telescope observed the comet's chemical composition. Astronomers found carbon monoxide, water ice, and a cocktail of other organic molecules, the building blocks of chemistry, the raw materials from which life constructs itself. The comet was, in essence, a frozen time capsule from the early universe, and its contents were speaking a chemical language that planetary scientists found deeply familiar. The European X-ray telescope's RISM, along with ESA's XMM Newton, observed 3I/Atlas in X-ray light, making it the first interstellar comet ever observed in the X-ray spectrum. The X-ray glow they detected, a diffuse luminosity surrounding the nucleus, was produced by solar wind particles interacting with the gases streaming off the comet's surface. This is a phenomenon called charge exchange, and it's been seen in comets from our own solar system before. The fact that 3I/Atlas showed the same behavior was significant. It meant that despite its alien origin, despite having spent 11 billion years in interstellar space, this comet was still playing by the same physical rules we know. The universe, it turns out, is consistent. The comet's color was measured across multiple wavelength bands. Came out reddish, significantly redder than our solar system's own comets. That redness is thought to be caused by a surface layer of complex organic molecules, called tholins, that form when simpler ices are irradiated by cosmic rays over billions of years. The depth of that reddish coloring was another data point suggesting the object's extraordinary age. The longer you marinate in cosmic radiation, the more dramatically your surface transforms. 11 billion years of cosmic ray exposure will do remarkable things to an icy surface. Astronomers also noticed something distinctive about the coma, the cloud of gas and dust surrounding the nucleus. In September 2025, observers reported an unusual green glow around 3I/Atlas. That green color almost certainly came from diatomic carbon molecules, C2, being energized by sunlight. It's a phenomenon seen in solar system comets too, but the intensity and particular character of 3I/Atlas's green halo attracted immediate scientific attention. The dust production was estimated at approximately 0.1 to 1 kilogram per second, an almost unimaginable amount of material being shed from the comet's surface every single second. Every second, while you were watching the news, while you were eating breakfast, while you were doing everything you do in a single second of your life, 3I/Atlas was losing a kilogram of itself to the warmth of a sun it had never encountered before. It was, in every measurable sense, extraordinary. But here is the question that the ancient astronomers would have asked. The question that, in some form, they did ask. Not what is it made of? Not how fast is it moving? Those are the questions of modernity. The ancient question was simpler and in some ways more profound. What does it mean? Let's talk about the Enuma Anu Enlil. If you haven't heard of it, you're not alone. It doesn't get much press in the 21st century. But in terms of sheer historical significance, in terms of what it tells us about the human relationship with the sky, it belongs in a conversation with the Iliad and the Bible and the Vedas. The Enuma Anu Enlil is a massive collection of Babylonian astronomical omens compiled between approximately 1500 and 1000 BCE, though it draws on astronomical traditions that reach back to at least 2500 BCE, the early Sumerian period. The name translates roughly as when Anu and Enlil, the sky god and the storm god of the Mesopotamian pantheon, and it comprises approximately 70 clay tablets containing more than 7,000 individual entries. Each entry follows the same basic structure. If this celestial event occurs, then this earthly consequence will follow. If Jupiter is in this position when the moon rises, then the harvest will be abundant. If Mars appears in this quadrant of the sky at this time of year, then the king must be cautious. If a star with a tail appears from the region of the great water and moves against the natural order of the heavens, well, then things get complicated. The Enuma Anu Enlil is not astrology in the modern pop culture sense. It is not horoscopes. It is not the vague, hedge-everything predictions of a newspaper column. It is the product of centuries, in some cases millennia, of systematic, rigorous observation by people who were genuinely brilliant and who took the sky with a seriousness that we have largely lost. The astronomer priests of ancient Mesopotamia, the scribes of celestial omens, as they called themselves, maintained records spanning generations. They identified the synodic periods of planets. They cataloged the risings and settings of stars with reference points accurate to within fractions of a degree. They predicted eclipses. They noticed patterns in phenomena that modern astronomers are still studying. And they noticed comets. The Sumerian and Babylonian records contain dozens of references to objects that behaved like comets. Sudden appearances of hairy stars or stars with tails that moved unpredictably, brightened rapidly, and then faded. The cuneiform records use specific terminology. The word for what we would call a comet was something like Mulbaber in Sumerian, a bright white star, or in Akkadian, Kakab-Zapu, meaning a tufted or bristled star, a reference to the comet's tail. Now, here is where things get interesting, and I want to be very careful here, because we are standing at the border between genuine historical scholarship and the kind of breathless ancient astronaut speculation that should make serious people uncomfortable. The Sumerians did not predict 3I/Atlas. They did not have hyperbolic orbital mechanics. They did not have telescopes. They did not have a concept of interstellar space in any form remotely approaching our modern understanding. But, and this is a genuinely significant but, they did observe comets with extraordinary care. They cataloged cometary behavior in ways that are sophisticated enough to have remained scientifically useful thousands of years later. And within their observational records and their mythological frameworks, there are threads that, when you pull them in 2025 and 2026, begin to feel remarkably resonant. This is not magic. This is not prophecy. This is something stranger and more interesting than either of those things. This is pattern recognition. And pattern recognition is the deepest thing that human minds do. Let's start with the mythology. The Mesopotamians had a name for the region of the sky from which 3I/Atlas appeared. In their celestial cartography, the southern sky, the region of Sagittarius and the surrounding constellations, which is where 3I/Atlas first appeared, was associated with what they called the Great Water. This was a cosmic ocean, a primordial sea that existed at the boundaries of the known world. In Sumerian cosmology, the god Enki, one of the three most important deities, the god of wisdom, water, and the deep, ruled this region. Now, the Sumerians divided the sky into three roads: the road of Anu, the equatorial band, the road of Enlil, the northern sky, and the road of Ea, or Enki, the southern sky. Objects appearing in the road of Ea, the southern sky, the great water, were considered particularly significant, particularly ominous, particularly worth paying close attention to. 3I/Atlas appeared from the direction of Sagittarius, deep in the southern sky, deep in the road of Ea, deep in the cosmic ocean. In the Enuma Anu Enlil, there is a category of celestial omen that deals specifically with objects that appear from the sea, from the southern sky, and that move with unusual speed against the wind of the heavens. The phrase, "against the wind of the heavens," refers to objects that move in a direction contrary to the normal apparent motion of celestial bodies, which for the Babylonians meant moving in a retrograde or unusually rapid fashion that didn't match the orderly procession of stars and planets they knew. 3I/Atlas, entering our solar system from the direction of Sagittarius on a hyperbolic trajectory, would have moved across the ancient sky in a way that was deeply anomalous. It would have appeared to move with unusual speed. It would have appeared to come from the great water. It would have appeared to be, in the language of the Enuma Anu Enlil, an object that has no path of its own. That phrase, "a star that has no path of its own," appears in several cuneiform tablets dealing with comet omens. Scholars of Mesopotamian astronomy interpret it as a reference to comets' unpredictable trajectories, their tendency to appear without the regular, foreseeable periodicity of planets. Unlike Venus, which the Babylonians could predict to the day, comets came and went according to no schedule that the ancient astronomers could calculate. This was, in fact, scientifically accurate. Most comets visible in ancient skies were either long-period comets returning from the Oort cloud on orbital periods of thousands of years, or they were comets like 3I/Atlas, true hyperbolic objects that had come from somewhere beyond our solar system and would never return. The ancient astronomers couldn't know the difference, but they observed the same fundamental quality. These objects followed no path that could be predicted by human mathematics. A star that has no path of its own. For a comet that had spent 11 billion years drifting through featureless interstellar space, that description achieves a kind of poetic accuracy that would take your breath away if you let it. But let's go deeper, because the mythology isn't the most interesting part. The most interesting part is the mathematics. It's a fact not widely known outside of the history of science community that the Babylonians, who inherited and dramatically expanded on the astronomical traditions of the Sumerians, developed mathematical techniques for predicting celestial phenomena that were, by any reasonable measure, centuries ahead of their cultural surroundings. The astronomical tablets known as the Astronomical Diaries of Babylon, a systematic record of celestial observations maintained by Babylonian scribes that spans roughly from 750 BCE to roughly 60 BCE, represent perhaps 7 centuries of continuous nightly observation of the sky. 7 centuries. Think about that. The United States of America is less than 2.5 centuries old. These astronomers maintained consistent, systematic records for 3 times longer than that. In the astronomical diaries, the scribes recorded planetary positions, lunar phases, weather, commodity prices, and occasionally the appearance of unusual celestial objects. The records are so detailed that modern historians of astronomy have been able to use them to verify the accuracy of our own orbital calculations, and to discover things about the ancient sky that would otherwise be completely lost to us. Now, here's where the 3I/Atlas connection becomes remarkable. Not through any mystical lens, through a purely mathematical one. The Babylonian astronomers, by the time of the period from roughly 400 BCE to the beginning of the Common Era, had developed what historians call the arithmetical or mathematical astronomy. Using what we now call Golier text Saros cycles and System A and System B tables, these astronomers could predict planetary positions with extraordinary accuracy, typically to within fractions of a degree. What they could not do with the mathematical tools available to them was identify a truly hyperbolic orbit. The concept of a hyperbolic conic section, the class of mathematical curve that describes the path of an object moving faster than escape velocity, was beyond what their numerical methods could capture. Euclid's work on conic sections existed by roughly 300 BCE, and the Babylonians had independent mathematical traditions of comparable sophistication, but the specific application of hyperbolic mathematics to orbital mechanics had to wait for Isaac Newton, who unified Kepler's laws of planetary motion with his own law of gravitation in the late 17th century CE. So the Babylonian astronomers could not have known, in any precise mathematical sense, that 3I/Atlas was on a hyperbolic orbit. They could not have calculated that it would never return. They could not have deduced its interstellar origin from its trajectory. But they observed something. They observed that certain comets behaved differently from others. Certain comets appeared suddenly, brightened rapidly, and vanished without ever showing the kind of periodic return behavior that was the hallmark of recurring comets. The great periodic comets, what we now know as Halley's Comet, which the Babylonians observed and recorded at multiple apparitions, recognizing its periodic nature, showed up reliably on a human timescale. The Babylonians tracked Halley's Comet from at least 164 BCE, and there are possible records of observations going back much further. But then there were the others, the ones that came once, blazed across the sky, and never came back. These were catalogued separately. These were treated with special significance. These were the comets that the scribes described as strangers, a remarkably direct word choice for objects we now know are literally strangers, visitors from other star systems. The concept of the stranger star appears in Babylonian astronomical texts in a specific ritual context. When a comet of unusual behavior appeared, moving too fast, coming from the wrong direction, displaying characteristics inconsistent with the catalog of known periodic comets, there were specific astronomical and ritual procedures that the court astronomers were expected to follow. The comet was to be observed continuously. Its position was to be recorded every night. Its brightness, its color, the shape of its tail, the direction of its motion. All of these details were meticulously documented. And then the king was to be informed. This last part is key, because it tells us something important about how seriously the ancient Mesopotamians took these events. The Assyrian Royal Archives at Nineveh, discovered in the mid-19th century CE by the British archaeologist Austen Henry Layard, contain hundreds of letters from court astronomers to the king, describing their celestial observations and their astrological interpretations. These letters are extraordinary documents. They're written in a tone that is simultaneously respectful and urgent, scholarly and deeply practical. The astronomers understood that their observations had consequences, that what they saw in the sky affected decisions that would cost or save human lives. One of these letters, from an astronomer named Balassi to the Assyrian king Esarhaddon, written around 671 BCE, contains what scholars believe may be a reference to a cometary apparition. The letter reads, in translation, "The king's servant has seen a star like a torch. Its face was toward the west and it had a tail. This is not a star that has a path. It comes from the region of the fishtail. Let the king know." The region of the fishtail is almost certainly the constellation we call Pisces, the fish. In the ancient Mesopotamian celestial map, Pisces was associated with the southern sky, the great water, the realm of Ea. And the description, a star like a torch with a face toward the west, is a classic description of a sunward-pointing comet tail, which is always directed away from the sun, meaning toward whatever direction is opposite the sun from the comet's perspective. This is not a star that has a path. The astronomer Balassi knew. He knew that what he was looking at was not a normal celestial object. He couldn't have known the physics. He couldn't have known about hyperbolic orbits. But he could observe, and what he observed told him that this thing was different. This thing was outside the normal catalog of the heavens. This thing was, in the most literal sense of the word, alien. He was right. And now, in 2025, we have the tools to tell him exactly how right he was. Here's a fact that should rewire something in your brain. The Sumerians and Babylonians divided the sky into what they called the 3 stars each, lists of 3 stars associated with each month of the year, organized according to the 3 great celestial roads of Anu, Enlil, and Ea. These star lists, among the oldest systematic catalogs of celestial objects in human history, formed the foundation of what would eventually become the Greek system of constellations that we still use today. The zodiac, the 12 constellations through which the sun appears to move over the course of a year, was a Babylonian invention. The specific names and arrangements of the zodiacal constellations were in place by around 400 BCE, but they were built on observational foundations going back to at least 1200 BCE, and possibly further. The constellation Sagittarius, the Archer, the direction from which 3I/Atlas appeared, occupied a specific and important place in this ancient celestial framework. The Babylonians knew the constellation as Mul.Pa.Bil.Sag, the bow star, and it was associated with the god Nergal, the ruler of the underworld. The stars of what we call Sagittarius pointed, in the ancient sky-reading tradition, toward a zone of particular significance, a region that the Babylonians understood, though they couldn't see it directly, as somehow different from the rest of the sky. Here's the thing. Sagittarius points toward the center of the Milky Way galaxy, the densest, most active, most complex region of our galactic home. A region teeming with stars, literally billions of stars packed into a core that, at its center, contains a supermassive black hole 4 million times more massive than our sun. The Babylonians didn't know about galactic centers. They didn't know about black holes. They didn't have any concept of the galaxy as a structure, let alone our position within it. And yet they felt something. The sky in the direction of Sagittarius was denser with stars than in other directions. The Milky Way was brightest and most magnificent in that part of the sky. The ancient astronomers noted this. They associated that direction with depth, with vastness, with the underworld, with things that were beyond the normal human-accessible sky. And 3I/Atlas came from that direction. It came from the densest region of the galaxy, from the direction the ancient Babylonians associated with the deep, the dark, the profound, the beyond, from the region of the fishtail, from the great water, from the road of Ea. Say what you will about the interpretive frameworks, the mythology, the astrology. The observation was accurate. Something extraordinary came from that direction. Something ancient and strange. Something that had no path. There is a Sumerian myth that has received considerable scholarly attention in recent decades. It's the story of the Anunnaki, the great gods of the Sumerian pantheon, and their creation of humanity. The myth, preserved in various forms on clay tablets spanning thousands of years, tells of gods who came from the heavens, who shaped the natural world, and who seeded humanity with specific abilities and purposes. Now, I want to be absolutely clear about something. I am not going to suggest that the Anunnaki were aliens. I am not going to tell you that ancient Sumerians were visited by extraterrestrial beings who gave them their astronomical knowledge. That is not what the evidence shows. The evidence shows that the Sumerians developed their astronomical traditions through exactly the same mechanism that all human knowledge develops: careful observation, systematic record-keeping, generational transmission, and the kind of slow, cumulative intelligence that is the most distinctively human thing about us. What I am going to tell you is something considerably more interesting than ancient aliens. In the Sumerian texts, there is a recurring concept: the idea that things of great importance, things that shape the world, come from outside the normal order. They descend from the sky. They arise from the deep water. They arrive from a direction that is not part of the everyday landscape. This mythological structure, the outsider who arrives and changes everything, is essentially universal in human storytelling. It appears in every culture that has ever left records. It appears because it describes something real. The cosmos is not a closed system. Things come from outside. Things arrive from the dark. Things change the established order, not because the established order was wrong, but because the universe is far larger and more dynamic and more astonishing than any stable order can contain. 3I/Atlas was a physical embodiment of that mythological archetype. A genuine outsider, an actual arrival from beyond, an object that spent 11 billion years outside our little corner of the cosmos and then, for a few extraordinary months in 2025, passed through our neighborhood, let us study it, let us learn from it, and then continued on its way. The Sumerians would have understood this immediately. Not the orbital mechanics, not the spectroscopy, not the X-ray observations, but the fundamental nature of the event. Something came from outside. Something arrived from the abyss. Something visited us and departed before we could truly understand what we had seen. They would have written it on a clay tablet because that is what you do when something important happens. You write it down. You make it part of the permanent record. You say to whoever comes after you, "We were here and we saw this thing and it mattered." Let's talk about the Mul. Apin tablets. Mul. Apin, the name means the plow star, referring to the constellation we call Triangulum, is one of the most important astronomical compilations from ancient Mesopotamia. Compiled around 1000 BCE but drawing on older traditions, it contains star lists, rising and setting tables, intercalation rules for the calendar, and, critically, a section on unusual celestial phenomena. That section includes guidance for what an astronomer should do when a star appears that is not in the path of the moon. Meaning, not along the ecliptic, not a planet or moon or sun, but something that appears in an unusual part of the sky and behaves anomalously. The Mul. Apin texts describe such objects as potential signs of the king, omens that require immediate interpretation and immediate action. The observation protocol was specific. Note the direction of appearance, the direction of travel, the color, the brightness, and whether the object has a beard, a tail. The presence or absence of a tail, and the direction in which the tail points, were considered particularly significant. A tail pointing upward, toward the zenith, away from the horizon, was interpreted differently from a tail pointing downward or sideways. A tail that changed direction over successive nights was considered especially ominous. These observations are, from a modern astronomical perspective, remarkably sophisticated. The direction a comet's tail points is determined by the pressure of solar radiation and solar wind acting on the dust and gas streaming from the nucleus. The tail always points generally away from the sun. As a comet moves relative to the sun, as it approaches, swings around perihelion, and recedes, the direction of the tail changes accordingly. The ancient astronomers couldn't know the physics, but they could observe the phenomenon with extraordinary precision. 3I/Atlas had a particularly dramatic tail. As it approached the sun in the summer and fall of 2025, observers noted a dust tail and an ion tail, the two standard comet tails that we know result from solar pressure acting on dust versus charged particles. The ion tail pointed almost directly away from the sun, as ion tails always do. The dust tail curved gently, tracing the comet's path through space. From Earth's perspective, as the geometry changed over weeks and months, the orientation of these tails shifted. If there had been a Babylonian astronomer with a clear southern sky in the fall of 2025, they would have been watching intensely. They would have noted the tail. They would have noted the direction of travel. They would have consulted their tables. And then they would have written to the king. The letter might have read something like, "A star with a beard has appeared from the great water. It moves with the speed of a running god. Its beard shifts with each night. It comes from a direction not known in our tables. This is not a star of our heavens. This is not a star of our heavens." You could put that on the press release from the discovery team at Atlas and it would be entirely accurate. Let's slow down and talk about what the ancient astronomers actually got right. Because this is not a story about people being wrong in interesting ways. This is a story about people being right in ways that should genuinely humble us. The Babylonian astronomers correctly identified the difference between periodic and non-periodic comets. They couldn't calculate the orbital periods, but they could recognize that some comets returned and others didn't. This is a real astronomical distinction. Periodic comets have elliptical orbits. They return on timescales ranging from a few years to tens of thousands of years. Non-periodic comets, including interstellar visitors like 3I/Atlas, follow hyperbolic paths and never return. The ancient astronomers correctly identified that comets came from specific directions in the sky. Modern astronomy has confirmed that the distribution of long-period comets coming from our own or cloud is essentially isotropic. They come from all directions roughly equally. But interstellar comets, by contrast, come from specific directions determined by the sun's velocity through the galaxy. 3I/Atlas came from the direction of Sagittarius. Its trajectory, working backward, points toward a region of the galaxy densely populated with old stars, exactly the kind of stellar neighborhood where a comet aged 11 billion years would have originated. The ancient astronomers correctly associated the southern sky, the road of Ea, the great water, with things that were deep, ancient, and beyond the normal order. The center of the Milky Way galaxy is in the direction of Sagittarius. The galactic center is the oldest, densest, most complex part of our galaxy. It is where stars have been forming for the longest time. It is the direction from which the most ancient cosmic objects might reasonably be expected to arrive. Now, I am not saying the ancient Mesopotamians understood galactic structure. They didn't. I am saying that sustained, careful observation of the sky over centuries and millennia allowed them to build a mental map of the cosmos that encoded real information. Information they couldn't articulate in modern terms, but information that was genuinely accurate. The human brain, confronted with a night sky and given a few thousand years, will find patterns. Some of those patterns are real. Some of those patterns are artifacts of the pattern-seeking process itself, meaningful to the human mind but arbitrary in physical terms. The challenge always is telling the difference. The Babylonian astronomers were, in this sense, scientists, imperfect scientists, working within a framework that mingled empirical observation with theological interpretation. But scientists nonetheless. They understood the fundamental scientific imperative. When something unusual happens, you watch it carefully, you record what you see, and you try to connect it to what you already know. 3I/Atlas was, from any observational perspective, unusual. It came from the great water. It had no path. Its beard shifted every night. They would have watched it carefully. They would have connected it to everything they already knew. And some of what they knew, embedded in thousands of clay tablets, encoded in mythological language, preserved through the transmission of astronomical tradition from Sumer to Babylon to Greece to us, was genuinely correct. Now let's talk about something that doesn't get nearly enough attention in popular science coverage of discoveries like 3I/Atlas. Let's talk about what the ancient astronomers were actually doing when they looked at the sky and felt that something mattered. They were doing cosmology, not in the technical modern sense, not with dark matter and cosmic microwave background radiation and inflationary epochs, but in the original, deepest sense of the word. They were trying to understand the structure of the universe and humanity's place within it. The Sumerian cosmological model, insofar as it can be reconstructed from the texts, was remarkably sophisticated for its time. The universe was understood to have a structure. There was the sky above, the earth in the middle, and the underworld below. The sky was populated by the gods, the heavenly bodies, whose movements and relationships determined the course of earthly events. The earth was a plate floating on primordial waters. The underworld was the realm of the dead. This model was wrong in its specifics. The earth is not a plate. The sky is not the realm of gods. But the underlying intuition that the universe has structure, that the elements of that structure are in dynamic relationship with each other, that understanding the large-scale organization of things is crucial to understanding the small-scale events that affect human lives, that intuition is correct. It is the intuition that drives all of modern cosmology. And the ancient astronomers' conviction that events in the distant sky have consequences for events on Earth, that the behavior of celestial objects is relevant to the human condition, is also, in a deep sense, correct. Not in the astrological sense. Not in the Saturn in your 7th house means your romantic life is complicated sense. In the sense that we are physically embedded in the cosmos. The light of ancient stars makes agriculture possible. The gravity of the moon moves our oceans. The radiation of the sun shapes our atmosphere and our climate. The cosmic environment in which our solar system is embedded has shaped the history of life on Earth in ways we are still discovering. An interstellar comet coming from 11 billion years ago and another solar system, carrying chemical compounds forged in the earliest epoch of the galaxy, passing through our neighborhood and showering its dust into our space. This is not an event without consequence. We absorbed photons from 3I/Atlas. Our instruments touched it with their instruments. We learned from it. We were changed by it in the small but real ways that knowledge always changes us. The Sumerian astronomer on his rooftop pressing wedge marks into clay, recording the star with a beard from the great water. He was part of a chain of causation that leads, for 1,000 years later, to the James Webb Space Telescope and the Parker Solar Probe and the Hubble Space Telescope and the thousands of astronomers who devoted months of their professional lives to understanding this visitor from the abyss. He was wrong about the gods. He was right about the importance. Let me tell you about a clay tablet found in Nineveh, part of the library of Ashurbanipal, the last great king of the Assyrian Empire, who ruled from 668 to 627 BCE. Ashurbanipal was, among other things, a scholar unusual for a warrior king, but not unprecedented. He collected clay tablets from across the ancient world, building what was perhaps the first great library in human history. The library at Nineveh contained tens of thousands of tablets covering everything from legal codes to literary epics to astronomical observations. Among the tablets in that library was a copy of a much older text, a Sumerian myth called The Lament for the Destruction of Ur. The myth describes a catastrophe that befell the city of Ur, one of the great cities of the Sumerian civilization, sometime around 2004 BCE. In the myth, the catastrophe is attributed to the decision of the gods, and it is described in astronomical terms. A specific star configuration, a specific set of celestial events, preceded the disaster. Now, historians are divided about what actually happened to Ur around 2000 BCE. There is archaeological evidence of significant disruption. There may have been a combination of factors: climate change, political upheaval, possibly an invasion by the neighboring Elamites. The astronomical omens in the myth are probably a later theological interpretation rather than a contemporaneous scientific observation. But here's what's interesting. The myth describes, among other celestial events, a star from beyond the known sky, moving without regard for the paths of heaven. Scholars have debated this passage for decades. What was it referring to? A particularly bright meteor? An unusual planetary conjunction? A comet? We don't know. We can't know with certainty. The ancient record is too fragmentary, too contaminated by mythological overlay, too distant from us in time to allow precise reconstruction. But the phrase itself, a star from beyond the known sky, is extraordinary. It suggests that the ancient astronomers had a concept of a sky that was known, a regular, predictable, mapped domain, and a sky that was beyond, something larger, stranger, and fundamentally unpredictable. This is not a bad model. The known sky corresponds to what we might call the inner solar system, the planetary domain, the realm of objects that move on predictable, calculable paths. The beyond corresponds to the outer solar system, the Oort cloud, interstellar space, the domain of the unpredictable, the ancient, the strange. The Sumerians and Babylonians couldn't see that far. but they could feel the boundary. They could sense, through the accumulated evidence of generations of careful observation, that the sky had edges. That beyond those edges was something they couldn't fully characterize. Something that occasionally sent emissaries into the familiar domain. A star from beyond the known sky, 11 billion years old, arriving at 58 kilometers per second from the direction of Sagittarius. With a nucleus that might be as large as 5.6 kilometers and a tail millions of kilometers long. 3I/Atlas was exactly that. Let's talk about something more speculative. Not wild speculation, not ancient aliens or prophecy. Scientific speculation. The kind of speculation that scientists are supposed to do carefully while remaining clear about what is known versus what is plausible. There is a hypothesis in modern planetary science called panspermia. In its simplest form, it suggests that the building blocks of life, organic molecules, amino acids, perhaps even microbial life itself, may be distributed throughout the galaxy through the transport of material from one planetary system to another. The vectors for this transport could include asteroids, comets, and interstellar objects. The James Webb Space Telescope's observations of 3I/Atlas were, in part, motivated by this possibility. The comet carried complex organic molecules. It came from a solar system that was 11 billion years old. It is at least conceivable, not certain, not even particularly likely, but conceivable, that it carried something more than chemistry. Now, I want to be very careful here. There is no evidence that 3I/Atlas carried life. None. The data collected during its brief passage through our solar system showed the presence of organic molecules consistent with what we'd expect from a natural comet, from a natural evolution of chemistry in the cold conditions of interstellar space. Nothing anomalous. Nothing that requires biological explanation. But the panspermia hypothesis, the idea that the ingredients for life, or perhaps life itself, travel between the stars on cosmic hitchhikers, is taken seriously by serious scientists. And 3I/Atlas was, by definition, exactly the kind of object through which such transfer might occur. Here's where the ancient angle becomes interesting again, because the ancient Mesopotamians had a version of this idea. Not panspermia, not in any modern sense, but they had a profound and persistent belief that certain kinds of knowledge, certain gifts that made human civilization possible, came from beyond the normal order of things. From the sky, from the sea, from outside. The Sumerian myths are full of a category of being called the Apkallu, the seven sages. They are described as half human, half fish, and they are said to have appeared from the sea. Specifically, the Persian Gulf, the Great Water to the south, and taught humanity the arts of civilization. Writing, architecture, agriculture, astronomy. The myths say these gifts came from outside the normal human domain. Now, the Apkallu myths have a perfectly straightforward anthropological interpretation. The Mesopotamian civilization emerged near water, between the Tigris and Euphrates, and drew on maritime trade connections with other cultures to its south. The knowledge from the sea may simply be a mythological encoding of cultural diffusion, ideas and techniques arriving via trade routes from other civilizations. But there is another layer to consider. The gifts the Apkallu brought, astronomy, mathematics, agriculture, writing, are the gifts that allow a species to understand its place in the cosmos. They are the gifts that allow a primate on a planet orbiting a middling yellow star to look up at the sky and recognize, across the vast darkness, the arrival of a visitor from another solar system. Whether or not the Sumerians meant anything like this with their myths, the resonance is striking. We received the gift of understanding from somewhere outside ourselves, from the accumulated wisdom of generations, from the systematic practice of observation and record-keeping, from the tradition of science that links the astronomer-priests of ancient Nippur to the astronomers of the Atlas telescope in Chile who first spotted 3I/Atlas on July 1, 2025. The gift came, in a very real sense, from outside. There is a cuneiform text known as the Astronomical Diary for 164 BCE. In it, a Babylonian scribe records the apparition of Halley's Comet, one of the earliest confirmed records of this famous periodic visitor. The scribe notes the comet's position, its brightness, the direction of its tail. He notes the date. He notes the weather. He does not express wonder. He expresses precision. This is something I want you to sit with for a moment. because it tells us something important about these ancient astronomers. They were not standing on their rooftops with their mouths open, paralyzed by astonishment. They were doing science. They were observing, measuring, recording. The wonder was there. It had to be in the presence of such a sky, but it was disciplined wonder. Wonder in service of understanding. The scribe recording Halley's Comet in 164 BCE was working within an observational tradition that had been maintained, night after night, for centuries. He had colleagues, predecessors, successors. He had a methodology. He had archives. He had what we might call, without too much anachronism, a scientific community. The astronomers who discovered 3I/Atlas were working within a tradition that descends, in a direct and traceable line, from that Babylonian scribe. The Atlas survey system, the digital sky surveys, the automated detection algorithms, the worldwide network of observatories that confirmed the discovery within hours, all of this is the contemporary form of the same human impulse. Watch the sky. Record what you see. Share the results. Build on what others have done before you. 3I/Atlas was spotted on a Tuesday night in Chile by a robot. The robot sent an alert. A human astronomer looked at the alert on a computer screen, recognized the anomaly, alerted colleagues. Within 48 hours, observatories on 5 continents had turned their eyes to the same point in the sky. This is not so different in its essential structure from what happened when a Babylonian scribe spotted something unusual and sent a letter to the king. The technology is unrecognizably different. The underlying human behavior is the same. We see something extraordinary. We tell each other. We try to understand it together. We are, at our best, what that Babylonian scribe was at his best. Watchers, recorders, translators of heaven's language. Here is the most haunting thought I can offer you. The one that wakes you up at 3 in the morning if you let it in. 3I/Atlas is 11 billion years old. It was born in a solar system around a star that no longer exists. That star burned out billions of years ago, leaving, depending on its mass, a white dwarf, a neutron star, or a black hole. The planet that flung 3I/Atlas out of its solar system no longer exists in any recognizable form. The solar system itself is probably unrecognizable, if it still exists at all. The stellar neighborhood in which that solar system formed has been rearranged by 11 billion years of galactic dynamics. Everything about the origin of 3I/Atlas has been erased by time. Everything except the comet itself. The comet was there. It was there when the parent star was alive. It was there when the planet that ejected it was a young, turbulent world. Maybe a world with volcanoes, maybe a world with oceans, maybe a world with something stranger than either of those. It was there, floating in the outer reaches of an alien solar system, being cold and patient and ancient, when the chain of events that would eventually produce Earth and life and human beings and telescopes was just beginning 3 solar systems away, in a molecular cloud that would one day collapse to form our sun. 3I/Atlas is older than Earth by almost 3 times Earth's age. It is a contemporary of the earliest universe. It contains, locked in its ice, molecules that formed in conditions we can barely model mathematically, the cold, radiation-bathed environment of an alien outer solar system 11 billion years ago. When the Hubble Space Telescope photographed 3I/Atlas in July 2025 and showed us a teardrop-shaped coma of dust streaming from a nucleus we couldn't quite resolve, we were looking at something that was already ancient beyond comprehension when the dinosaurs walked the Earth. We were looking at something that formed while Earth's sun was still a cloud of gas. We were looking at a message from a universe that barely resembles the one we know. The ancient Mesopotamian astronomers, recording their celestial omens on clay tablets, were trying to translate messages from heaven into earthly meaning. They believed that the behavior of celestial objects encoded information about the fate of kings and kingdoms, harvests and wars, floods and droughts. They were wrong about the specific encoding, but they were not wrong about the fundamental idea. Celestial objects do carry information. 3I/Atlas carried information about the chemistry of an ancient solar system, about the composition of cosmic ices 11 billion years old, about the distribution of interstellar objects in the galaxy, about the processes by which solar systems form and eject material into the interstellar medium. Reading that information, translating it from the language of spectral absorption lines and orbital mechanics and chemical abundances into the language of understanding, is exactly what the Atlas team and the Hubble team and the Webb team and the hundreds of astronomers who studied this object in 2025 were doing. They were, in a very real and very ancient sense, translators of heaven's language. The Sumerian concept of the universe was not, at its core, a passive one. The Sumerians did not believe that the cosmos was indifferent to human existence. They believed that the cosmos was engaged with human existence, not in a warm and comforting way necessarily, but in an attentive way. The movements of the sky mattered because the sky was paying attention. We have lost this conviction, and in most respects that loss is a gain. The sky is not paying attention to us. The universe is not arranged for our benefit or our instruction. 3I/Atlas did not come to deliver a message to humanity. It came because orbital mechanics is orbital mechanics, and if you spend 11 billion years drifting through the galaxy, eventually you will drift near something. But here's what's interesting. From a certain perspective, not a mystical one, just a factual one, the universe is paying attention. Not intentionally, not divinely, but structurally. The cosmos is constructed in such a way that it produces observers. It produces, over time, through the completely impersonal process of nuclear fusion and planetary formation and biological evolution and cultural development, creatures that look back at it. Creatures with eyes, with instruments, with mathematics, with curiosity. It produces creatures that look at a comet from another solar system and ask, "Where did you come from? How old are you? What are you made of? What does your existence tell us about the universe before we were part of it?" The universe produced those questions, not on purpose, but it produced them. It produced the Sumerian astronomer on his rooftop, pressing marks into clay. It produced Ashurbanipal's library. It produced the Greek astronomers who inherited and extended the Babylonian tradition. It produced Newton and his calculus and his law of gravitation. It produced the Atlas telescope in Chile and the algorithms that detected an anomalous moving point of light on the night of July 1, 2025. The universe is structured such that it eventually looks at itself. Through us. 3I/Atlas spent 11 billion years drifting through a universe that had no eyes. And then, for a few extraordinary months, it passed through the one corner of the cosmos that had grown itself a pair. Through us. Through our instruments. Through our mathematics and our curiosity and our stubborn, ancient conviction that the sky is worth watching carefully. The Sumerians would have called that meaningful. They would have written it on a clay tablet. I think they were right. Let me tell you what we know, now that 3I/Atlas has left us. Now that it's headed back out into the dark, carrying with it the warmth of our sun, which is already fading as the distance grows. We know its size. Somewhere between 440 meters and 5.6 kilometers across. We know its composition: water ice, carbon monoxide, complex organic molecules, a reddish surface layer indicating billions of years of cosmic ray processing. We know its speed, 58 kilometers per second relative to the sun when it arrived, accelerating to 68 kilometers per second at closest approach, now decelerating back to escape velocity as it climbs out of the sun's gravity well. We know its origin. The thick disk of the Milky Way galaxy, a population of ancient stars, likely a solar system that is now unrecognizable or gone entirely. We know its age. Approximately 11 billion years, give or take a few hundred million. We know it showed us X-rays, the first interstellar comet ever to be observed in that wavelength. We know it showed us a dramatic coma, a teardrop-shaped dust cloud that Hubble photographed with extraordinary beauty. We know it showed us a green halo of diatomic carbon. We know it followed the most dynamically extreme orbit ever measured in our solar system. We know that every major space telescope, every planetary mission with eyes to turn, looked at it. Hubble, Webb, TESS, XRISM, XMM Newton, Parker Solar Probe, the Mars rovers, the Europa Clipper, ESA's Mars Express and Trace Gas Orbiter and JUICE, NASA's MAVEN and MRO, a fleet of human-made eyes, all pointed at a single ancient visitor from the deep. That's what we know. Here's what we don't know. We don't know if it carried life. We don't know the exact chemistry of its nucleus because we couldn't land on it. We don't know where precisely it came from, because working backward through 11 billion years of galactic dynamics doesn't give you an exact address. We don't know how representative it is of the interstellar population, whether there are millions of objects like it drifting through our galaxy at any given moment, or whether it is something rare. We don't know, with certainty, whether it is truly the third interstellar object we've detected or whether we missed earlier ones, or how many we've missed in the past. We don't know what it saw in 11 billion years of drifting, what stars it passed near, what solar systems it flew through, what events, stellar collisions, supernovae, the births and deaths of planetary systems it witnessed in its long, dark, silent journey. These are the questions that will drive the next generation of interstellar object research. The questions that will shape the next space missions, the next survey programs, the next generation of astronomers. The questions that the Sumerians would have recognized, even if they couldn't have formulated them. The questions that their observations, recorded in cuneiform on clay tablets 4,000 years ago, helped make possible in the slow, cumulative, multigenerational way that all human knowledge is made possible. There will be more. That is one of the clearest lessons of 3I/Atlas. We've now detected 3 interstellar objects, Oumuamua in 2017, 2I/Borisov in 2019, 3I/Atlas in 2025. In less than a decade. This tells us something important. Either we are extraordinarily lucky, or these objects are far more common than we thought, or, most likely, the dramatically improved sensitivity of modern sky survey systems has finally crossed the threshold of detection capability necessary to find them. The Rubin Observatory, under construction in Chile and beginning its legacy survey of space and time, will eventually survey the entire southern sky every few nights with unprecedented depth and resolution. If there are interstellar objects passing through our solar system, the Rubin Observatory will find them, potentially many of them per year. Each one will be a message from another solar system. Each one will be a piece of evidence about the chemistry, the dynamics, and the history of a part of the universe we cannot directly visit. Each one will be a test of our understanding of planetary formation, of galactic dynamics, of the distribution of material through the interstellar medium. And each one, I guarantee you, will be greeted by something that looks a lot like what a Babylonian astronomer felt when he spotted an object in the sky that had no path of its own. Wonder, urgency, the irresistible conviction that this matters, that this requires attention, that this needs to be written down. The ancient astronomers were doing, in the only way available to them with the tools they had, exactly what the astronomers of 2025 were doing with theirs. Watching the sky for the unusual, recording it carefully, trying to understand what it means. The technology has changed. The underlying impulse has not changed in 10,000 years. And that's the most extraordinary thing about 3I/Atlas in the end. It's not just a story about an ancient comet from another solar system. It's a story about human continuity, about the unbroken thread of skywatching that connects the mud-brick rooftops of Nepal to the concrete piers of the Atlas telescope in Chile, about the species-wide conviction, maintained through wars and empires and dark ages and revolutions, that the sky matters and is worth watching carefully. The Sumerians couldn't have predicted 3I/Atlas, but they created the tradition that made its discovery possible. Every generation of astronomers who looked up and wrote down what they saw was adding a link to the chain. Every clay tablet, every papyrus, every parchment manuscript, every published paper, every dataset archived on a server. Every link made the chain longer and stronger, until the chain was finally long enough and strong enough to reach across 11 billion years and touch the surface of a comet from another world. Here is the final piece of the puzzle, the one that brings everything together. The Sumerians had a word for the night sky, and it was also the name of the sky god, the highest deity, the father of all gods, the ruler of heaven. The word and the concept of the sky were, for the Sumerians, inseparable. The sky was not just a physical space above them. It was a living, intentional, enormously powerful presence. It was the context within which all things happened. It was the frame of all frames. We have a different word now. We call it the universe. We know it is not intentional. We know it is not a deity. We know it is vastly larger than the ancient Mesopotamians could have imagined, 93 billion light-years across, containing 2 trillion galaxies, each containing hundreds of billions of stars, with a history spanning 13.8 billion years and a future, depending on which model you trust, spanning either trillions of years or effectively infinity. The Sumerians, and was the sky visible from a rooftop in Mesopotamia, bounded by the horizon and the stars. Our universe is something they could not have conceived of in any technical sense. But the feeling of being small and aware within something vast and indifferent and incomprehensibly ancient, that feeling, I think, is the same. You can stand on that rooftop in Nepal and feel it. You can stand under the dome of an observatory in Chile and feel it. You can look at a Hubble image of 3I/Atlas, a teardrop of dust and ice streaming away from a nucleus we can barely resolve, and feel it. The universe is enormous and ancient and, for the most part, has no idea we exist. And yet here we are, watching, recording, asking questions, pressing marks into whatever medium we have available, clay tablets or telescope archives, so that whoever comes after us will know that we were here, and we saw this thing and it mattered. 3I/Atlas came from a universe that didn't know we existed. A universe 11 billion years deep, from a solar system long dead, carrying chemistry older than Earth. It came through our neighborhood on its hyperbolic trajectory, touched by the heat of our sun for a few months, observed by our most sophisticated instruments, studied by thousands of scientists on 6 continents, and then it left. It left. It's out there now, receding, getting colder, getting darker, heading back toward the interstellar medium from which it came. It will travel for billions of years. It will probably never encounter another star system, though the odds are not zero. It will carry the photons we bounced off it, the information we gathered, the brief warmth of our sun embedded in whatever chemical changes those months of exposure produced on its ancient surface. Tiny record, tiny mark, almost nothing, but not nothing. The universe noticed us in the only way the universe ever notices anything. We passed near each other. We exchanged energy. We were, for a brief and extraordinary moment, in the same place at the same time. And we, unlike the comet, had eyes, and instruments, and words. And the ancient Babylonian astronomer, 4,000 years ago, watching a star with a beard from the great water, rising in the southern sky, doing what his tradition told him to do. Watching it, measuring it, writing it down, telling someone he was doing the same thing. Being present, bearing witness, translating heaven's language into human understanding, one clay tablet at a time. He didn't know what he was seeing. We didn't fully know what we were seeing in 2025 either, despite all our instruments, despite all our mathematics. We know more than he did. We will always know more than we currently do. That's the nature of the enterprise. But the enterprise itself, the watching, the recording, the wondering, that's 4,000 years old at minimum. That's as old as writing. That's as old as civilization. And 3I/Atlas, in its quiet, ancient, utterly indifferent way, connected us to it. A star from beyond the known sky, 11 billion years old. And for a few extraordinary months in 2025, ours to study. The clay tablets of ancient Mesopotamia are kept, now, in museums in London and Paris and Berlin and Chicago and Baghdad. Some of them have never been fully translated. Some of them contain astronomical records whose significance we are still working out. Some of them may contain references to celestial events that future generations of historians of astronomy, using techniques and tools we haven't invented yet, will identify as observations of interstellar objects. And in the archives of the Atlas Survey, in the data repositories of Hubble and Webb and TESS, in the preprint servers where hundreds of papers about 3I/Atlas were published in 2025 and 2026, there is a new kind of clay tablet. Digital, distributed, redundant, preserved against loss in ways that Ashurbanipal's library, buried under the sands of Nineveh for 2.5 millennia, was not. Future generations will read those records the way we read the cuneiform tablets, trying to understand what we saw, trying to place our observations in the context of what they know that we don't. Maybe they'll detect 10 interstellar objects a year. Maybe they'll have spacecraft that can intercept them. Maybe they'll know where they came from with more precision than we do. Maybe they'll understand things about the chemistry of 3I/Atlas that we couldn't measure, because they'll have instruments we haven't dreamed of yet. Maybe one of them, some future astronomer on some future rooftop, metaphorical or literal, will look at our records from 2025 and say, they saw it. They were watching. They wrote it down. And that will be true. Because we did. And we were. And we did. The sky keeps sending us messengers. From Oumuamua, the strange and thin and tumbling visitor of 2017, with its anomalous acceleration that defied easy explanation. From Borisov, the blue-tinged comet of 2019, carrying carbon monoxide ices from somewhere colder and stranger than anything in our own Oort cloud. From 3I/Atlas, the ancient one, the billion-year drifter, the teardrop of ice and dust from a dead solar system. Each one carrying a piece of the universe's history. Each one legible partially to human instruments. Each one a test of what we know and a reminder of what we don't. The Sumerians would have said the gods were speaking. We say the universe is structured in ways that allow us, improbably and beautifully, to read it. Both, in their different ways, are describing something real. Watch the sky. Write it down. Tell someone. This is what we do. This is what we have always done. This is what makes us human.